Hello, everyone. I hope you're doing very well today. We're going in this class to continue our subject of determinants that we started in the last video. In the last video, we learned how to calculate determinants of matrices 2 by 2 and 3 by 3. And today we're going to learn how to calculate determinants of higher order, like 4 by 4, 5 by 5, etc. In order to do that, we need to learn how to calculate the cofactor of a matrix and how to calculate the determinant based on the cofactor. And each element of the matrix has a different cofactor. So I'm going to show you how to calculate the determinants first, and then afterwards I'm going to solve an example of an exercise of a matrix 4 by 4. How to calculate the determinants of this matrix 4 by 4. So keep up with me. I'm going to share my screen with you now. So determinant of matrix n by n. This is an example of a matrix 4 by 4 in which I decided to, instead of putting numbers, putting letters, because it would be easier to explain the procedure of calculating the determinant this way instead of going to numbers directly. First, we need to learn how to calculate the cofactor of a matrix. For example, actually, I keep saying a matrix, but the cofactor, each element of a matrix has a cofactor. So, for example, let's learn how to calculate a cofactor of the element 1, 1. Element 1, 1, A1, 1 is the element of the first row and the first column. How do we calculate the cofactor of the element A1, 1, which I'm calling here C1, 1? It's minus 1 to the power of the index of the row plus the index of the column of that corresponding element. So if we're calculating the cofactor of the element A1, 1, it's minus 1 to the power of 1 plus 1. If it was the element 2, 3, it was going to be minus 1 to the power of 2 plus 3. This power times the determinant that I'm calling here D11. What is the determinant D11? D11 is the determinant of the matrix, the remaining matrix, after we take the original matrix and we remove the column 1 and the row 1. So if I eliminate the first row and the first column, it's going to remain what? Just these 9 elements here. 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, 3, 4, 4, 2, 4, 3, 4, 4. And then D11 is the determinant of this new matrix formed by only this element. If it was this element, for example, the cofactor of this element here, I was going to eliminate this line and this column. So whenever you decide to calculate the cofactor of an element of a matrix, when you calculate this determinant here, is the determinant that is originated by the remaining matrix after you take the original matrix and eliminate the line and the column of the elements which you want to calculate the cofactor for. Okay? So it's minus 1 to this power. For example, the element A11 was going to be minus 1 to 1 plus 1 times this determinant here. Okay? Right. So having the cofactor, how we calculate the determinant of a matrix? The determinant, and this is the most important line that I'm going to say today. The determinant of a matrix is the sum of products in which each product is the element of a specific line and its corresponding cofactor. So for example, choose a line. Let's say line 1. So the determinant is going to be A11 times its cofactor plus A12 times its cofactor plus A13 times its cofactor plus A14 times its cofactor. And you can choose any row or any column to do that. It doesn't need to be the first row. It doesn't need to be a row. It can be even a column, okay? And because of that, you can choose what column and what row you're going to consider to calculate the determinant. So depending on what row and what column you choose, the calculation can be easier or more difficult. I'm going to show you how. Let's see an example of calculating the matrix, the determinant of a matrix 4 by 4. Suppose we have this matrix here, okay? And we want to calculate its determinant. Like I said, the determinant of a matrix, let's take for example the first row. It's going to be each element, so the sum of each element times its corresponding cofactor. So A11 times C11 plus A12 times C12 plus A13 times C13 plus A14 times C14. Of course, in this example, I'm showing you, I chose the first row, and here's why. In the first row, there is an element which is 0. So when I consider the determinant, the last term, which is A14 times C14, I don't need to calculate the cofactor C14 because it doesn't matter what is its value. Because when I multiply its value by 0, it's going to make a contribution of nothing to the calculation of the determinant. So the more zeros you have in a row or in a column, the easier it's going to be to calculate the determinant based on this procedure that I'm showing you. So take this equation. Let's do the calculation now. So let's substitute each element of the matrix by its corresponding numbers. So A11 is going to be 4, A12 is going to be 5, A13 is going to be -3, and A14 is going to be 0. 0 times anything equals 0, so I'm not even going to consider it in the next line here. The determinant is going to be in the end what? 4 times C11 plus 5 times C12 minus 3 times C13. Okay? So look at this equation. The only thing we need to calculate now is the 3 cofactors, and then we can reach the final determinant of the original matrix, this one here, 4 by 4. So the cofactor of the element 1, 1, it's going to be -1 to the power of 1 plus 1 times the determinant of the remaining matrix after we eliminate the first row and the first column, which is this part here. -1 minus 3 minus 1 minus 3, 2, 3, 2 minus 2, 1, 1, 5. So we get to -1 to the power of 2, which is 1 plus 1, times 41, which is the determinant of this matrix. I encourage you to calculate the determinant of this matrix manually based on the procedure that I taught you in the last video. You're going to reach to 41. And -1 to the power of 2 equals 1. So 1 times 41 equals 41. Remember that whenever if you take -1 to any power which is even, you're going to reach 1. And if you take -1 to any power which is odd, you're going to reach -1. So since 2 is an even number, -1 times to the power of 2 equals 1. Let's calculate the second cofactor, which is -1 times -1 to the power of 1 plus 2 times the determinant of the matrix when you eliminate the row 1 and the column 2. So row 1 and column 2. So you're going to have these 4 numbers and these 6 numbers in the new determinant. -1 to the power of an even number, an odd number, it's going to be -1. So -1 to the power of 3, it's going to be -1. And the determinant here, it's going to be 7. If you do it manually, you're going to see that you're going to reach the value 7 in the end. -1 times 7, -7. Doing the same procedure for the cofactor 1, 3, it's going to be -1 to the power of 1 plus 3 times the determinant of the remaining matrix when we eliminate from the original matrix the row number 1 and the column number 3. Minus 1 to the power of an even number, 1. This determinant here, if you do the calculation manually, you're going to reach minus 27. 1 times minus 27 equals minus 27. Now let's substitute in the equation of the determinant the values of each cofactor that we have just calculated. 4 times C11, 4 times 41. Plus 5 times C12, 5 times minus 7. Watch out and pay attention for negative numbers, okay? Minus 3 times C13, minus 3 times minus 27. 4 times 41 equals 164. 5 times minus 7 equals minus 35. Minus 3 times minus 27 equals 81. If you do this calculation here, which is very simple, 164 minus 35 plus 81, you're going to reach to the determinant of the matrix, the original 4x4 matrix of 210. Okay? Pause the video whenever you feel you need some time to absorb what's being explained. Leave your comments here for any future exercise you want me to solve. Also, subscribe to the channel and put your likes. It counts a lot for us. Okay? You have a nice one. See you next time. Bye.